Right, so we're now doing mechanics and stats paper for further maths, summer 2014. So question 1, a smooth sphere P of mass 2m is at rest on a smooth horizontal surface. A horizontal impulse of magnitude 8 mu is given to P. Subsequently, P collides directly with a fixed smooth vertical barrier at right angles to P's direction of motion. Given that the coefficient of restitution between P and the barrier is 0.75, find the speed of P after the collision. Well, in this question, all you need to do is use the equation for momentum, which, because the impulse has magnitude 8 mu, and the mass of the sphere is 2m. So in order to have an impulse of 8 mu, the speed of the sphere must be 4u. And after the collision, the speed of separation must be the coefficient of restitution times the speed of approach. So v dash, the speed at which the sphere bounced back from the barrier, would be 4u times the coefficient of restitution, which is 0.75. And that would give you 3u. Question 2. The point O is on the fixed line L. Points A and B on L are such that OA equals 0.5 meter and OB equals 0.75 meter, with A between O and B. So let's try to draw a graph. O here. Of OA is 0.5. And then we have OB. Is 0.75. And now a particle P of mass m oscillates on L in simple harmonic motion with center O. The ratio of the kinetic energy of P when it's at A to its kinetic energy when it's at B is 12 to 11. Find the amplitude of the motion. So first we need to relate amplitude to kinetic energy, and this is done by relating amplitude to the velocity of the particle in a simple harmonic motion. So we have v squared is equal to omega squared, the angular frequency, times amplitude squared minus the displacement from the equilibrium squared, so x squared. So we know at point A, VA is equal to omega squared A squared minus 0.5 squared, which is the displacement 0.5, and VB squared is omega squared A squared minus 0.75 squared. And from the condition that the ratio between the kinetic energy is 12 to 11, we can also write down the equation a half VA squared, the kinetic energy at point A, is equal to 12 over 11 times a half VB squared, which is the kinetic energy at point B. And we can simplify that into 11A squared minus 0.5 squared is equal to 12 times A squared minus 0.75 squared. And we can then solve for A. So A squared is equal to 4, which means A is equal to 2. And this is the first part of the question. And now, given that the greatest speed of P is 0.6 meters per second, find the time taken by P to travel directly from A to B. So the point here is that the greatest speed of a simple harmonic motion, V max, is equal to the amplitude times the angular frequency, omega. So we know that 0.6, which is the maximum speed, is equal to 2 times omega. So omega will be 0.3. And in order to find time with given this to travel a given distance between 2 points, we need to use the inverse sine function. So what we need to do is t is equal to 1 over omega sine inverse sine of 0.75 over 2 minus inverse sine 0.5 over 2, and that will give you 0.439. Question 3. 3 small smooth spheres A, B, and C have equal radii and masses m, 9m, and km respectively. So we have A with mass m, B with mass 9m, and C with mass km, where k is a unknown variable. They are at rest on a smooth horizontal table and lie in a straight line, with B between A and C. The coefficient of restitution between any pair of spheres is E. Sphere A is projected directly towards B with speed u. Given that half of the total kinetic energy is lost as a result of the collision between A and B, find the value of E. A lot of these collision questions is really just constructing a set of simultaneous equations and try to find their solution. And this kind of simultaneous equation arises from some simple laws, for example, the conservation of momentum and Newton's law of restitution. And these laws will give you a set of simultaneous equations which you can use to solve whichever unknown you want to find. So now we want to find the value of E. By conservation of momentum, we know that before the collision, we have a total momentum of mu, and after the collision, we have mva, the speed of A after collision, and 9mvb, which is the speed of sphere B after collision, and this is the conservation of momentum. And we also have, from Newton's law of restitution, Vb minus Va is equal to E times U. And from these two equations, we can solve Va and Vb in terms of E and U. So Va can be found to be 1 minus 9 EU over 10, and VB is equal to 1 plus EU over 10. And we can construct a further equation from the fact that half of the total kinetic energy is lost So we know that half times a half mu squared, so a half of the initial kinetic energy is equal to a half mva squared plus a half 9mvb squared. And substitute in VA and VB from these two expression, we'll find a equation that's solely in E. And after solving that, we find E is equal to 2/3. And after B and C collide, they move in the same direction and the speed of C is twice the speed of B. Find the value of K. Well, what do we know? So first, we know that the velocity of VC, is 2VB dash. So the velocity of B after the collision. And also we know that by Newton's law of restitution again, VC minus VB dash is equal to EVB. And we found before that VB is U/6. Okay, and now we can find another simultaneous equation where 9mVB dash plus kmVc is equal to 9mVb. This is again the conservation of momentum. And that will lead you to the equation that 9VB dash plus 2kVB dash is equal to 13.5 VB dash. So K is equal to 9/4. Right, question 4. A smooth wire is in the form of an arc AB of a circle of radius A. The subtendon obtuse angle pi minus theta at the center O of the circle. It is given that sine theta is a quarter. The wire is fixed in a vertical plane with AO horizontal and B below the level of O. A small bead of mass m is threaded in the wire and projected vertically downwards from A with speed square root of 3/10 GA. Find the reaction between the bead and the wire when the bead is vertically below O. So in order to find the force, we need to apply Newton's second law, which states that F is equal to ma. And in order to arrive at that equation, we need to find what forces are acting on the bead at the bottom of the at the point vertically below O. So we'll have gravity acting downwards and a reaction force acting upwards. And we know that in a circular motion, we have acceleration v squared over A, where A is the radius of the circle, and that times mass m is equal to the total resultant force, which is just R minus mg. And we also know that from conservation of energy, a half v squared is equal to a half u squared plus g a, where v is the speed of the particle vertically below O. So from these two equations, we can eliminate v squared and find that R is equal to mu squared over A plus 3mg, where u is equal to square root of 3/10 GA. So that would give you 3.3 mg. Question part 2. Find the speed of the bead as it leaves the wire at B. Now, we use conservation of energy again to find VB. So a half mVB squared is equal to a half mu squared plus mGA sine theta, which is the amount of gravitational potential energy lost comparing to when the bead was at point O. And further, we can simplify that to be VB squared equals 0.3 plus 0.5 GA, and VB is now square root of 0.8 GA. Now show that the greatest height reached by the bead is an eighth of A above the level of O. Well, you have to use Suvat for this question, but you have to realize that only the component of speed in the direction vertically upwards is going to contribute to the greatest height reached. So we need to do a VB cos theta, which is equal to 3/4 GA square root, and H would be this velocity VB cos theta squared over 2g, which is just an application of Suvat equations, and that will give you 3A/8. And then after that, you need to subtract the difference between the height of point B and point O. So you need to do H minus A sine theta, and that will give you A/8. Question 5. A uniform rectangular thin sheet of glass ABCD, in which AB equals 8A and BC equals 6A, has mass 3/5 m. Each of the edges AB, BC, CD, and DA has a thin strip of metal attached to it as a border to the glass. The strips along AB and CD each have mass m, and the strips along BC and DA each has mass 1/3 m. Show that the moment of inertia of the whole object, glass and metal strips, about an axis through A perpendicular to the plane of the object is 128 ma squared. Well, let's just see how it would look like. So I have a metal object. So I have A, and then we know that AB is 8A and BC is 6A. And we know that the mass of the glass is 3/5 m, and the shorter sides of the steel edges would have 1/3 m, and the longer side will have m. And we know that DC is 8A and BC is 6A. Okay, and now all we need to do is find the moment of inertia about the center of mass of each simple object. So in this case, we have rod and a laminar, and we need to do a transformation using parallel axis theorem and combine everything together. in the end. So for glass, we have m, which is 3m over 5, times a third 5a squared, which is just from the formula booklet, plus 25a squared, which is the distance between the center of mass of the glass and A, which can be worked out using Pythagoras. And repeating that to side A, B, etc. And in the end, you'll find that I is equal to 128 A squared. And the second part of the question, the object is free to rotate about this axis, which is fixed and smooth. The object hangs in equilibrium with C vertically below A. It is displaced through a small angle and released from rest. Show that it will move in approximate simple harmonic motion and state the period of the motion. So I'm going to draw a graph. It's hanging from A, and this is its center of mass. Let's call it O. And when OA is displaced from its vertical position, there will be a force acting on it. And applying Newton's second law, we'll find that the equation of motion for the object is I d2 theta dt squared is equal to the total mass of the object minus 49 mg over 15 times the length OA, which is 5a, and then sine theta, so the component of gravity acting towards the equilibrium position. So if the angle is small, we can use small angle approximation. So we end up with I theta double dot is equal to minus 49g over 384 a theta, and that is so there's no I here, and that is the equation for simple harmonic motion, where this constant here is the angular frequency omega. And after knowing omega, we can just work out t, the time period, from the relationship t equals 2 pi over omega, and that will give you 17.6 square root a over g. Question 6. A pair of coins is thrown repeatedly until a pair of heads is obtained. The number of throws taken is denoted by the random variable x. State the expected value of x. This is a geometric distribution, and for a geometric distribution, the expectation value E of x is just 1 over the probability of success, which is 1 over a half times a half, and that will give you 4. And for the first part of the question, we're asked the probability that exactly 4 throws are required to obtain a pair of heads. So that is just the probability that x equals 4, and that will require 3 failures. So that's 3 over 4 to the power of 3, and exactly 1 success, and that will be 1 over 4, and that will give you 0.105. And the second part of the question, we're asked what's the probability that fewer than 6 throws are required to obtain a pair of heads. That is just a probability that x is less than 6, and that is 1 minus the probability that x is greater or equal to 6. And that is just 1 minus probability of 6 failures. So that will be 3 over 4 to the power of 6. Oh, sorry, that means 5 failures actually, because it's greater or equal to 6. So on the 6th throw, maybe it will be a success. So that will eventually give you 0.763. Question 7. The random variable t is the lifetime in hours of a randomly chosen decorative light bulb of a particular type. It is given that t has a negative exponential distribution with mean 1,000 hours. So in this case, mean is 1 over the parameter lambda, where lambda is used in the form f of t is equal to lambda e to the minus lambda t, and substituting the value of lambda, we will have 0.001 e to the minus 0.001 t, which is the form of a negative exponential distribution. And this is only valid for t greater or equal to 0. And when t less or equal to 0, the probability density function is just 0. And for the second part of the question, we are asked for find the probability that a randomly chosen light bulb of this type has a lifetime of more than 2,000 hours. And probability that t is greater than 2,000 is just 1 minus the probability that t is less than 2,000, and that's just f of 2,000, where f is the integral from 0 to t, f of t dt, and that will give you 1 minus e to the minus 2 bracket equals e to the minus 2. In the last bit, we have a display uses 10 randomly chosen bulbs of this type, and they are all switched on simultaneously. Find the greatest value of t such that the probability that they are all alight at time t hours is at least 0.9. So the probability that they are all still alight is just exponential of minus 0.001 t, or to the power of 10, and that is required to be greater than 0.9. So t is greater or equal to ln 0.9 over 0.01 minus, and that is equal to 10.5. Question 8. Weekly expenses claimed by employees at 2 different branches, A and B, of a large company are being compared. Expenses claimed by an employee at branch A and by an employee at branch B are denoted by X and Y respectively. A random sample of 60 employees from branch A and a random sample of 50 employees from branch B give the following summarized data. Using a 2% significance level, test whether on average employees from branch A claim the same as employees from branch B. Well, so with hypothesis testing, we should always write out our null hypothesis, H0, which is that mu x is equal to mu y, so the mean spending is the same. And the alternative hypothesis that mu x is not equal to mu y. And now, in order to investigate this hypothesis, we first want to find the estimated variance. So for x, we have we want the sum of x squared minus the sum of x squared over 60. And in order to make it an unbiased estimate, we need to divide it by the number of sample minus 1, so divided by 59. And similarly, we can calculate Sy. And after we've found this to be 240 and 270.4, from which we can estimate population variance for combined sample, which is S squared is equal to XX squared over 60 plus SY squared over 50. And we find out to be 9.408. So we now define a new variable Z is equal to 101 minus 95 and divided by S. So 101 is the mean of branch A and 95 is the mean of branch B, and we divide that by the estimated population variance for combined sample. And we find in this case to be 1.96. But after reading from the table, we know that for a this is a two-tailed test because it's trying to ask whether they are the same or not. So it's a two-tailed test. Z.99 has tabular value 2.326. And so we have to accept H0 that the claims are the same because 1.96 is less than 2.326. Question 9. So we have a random sample of 200 observations of continuous random variable x was taken, and the values are summarized in the following table. And we have found a function that we're trying to test the function's goodness of fit. The function is f of x equals 1 over x ln 8 in the region 1 and 8, between 1 and 8, and 0 otherwise. So show that p equals 39, correct to 2 decimal places, and find the value of q. This is just a application of probability density function. So p is just integral between 2 and 3, f of x dx, and that is easily found to be 39. And q, we can do the same. It's the integral from 4 to 5 of f of x dx. and that will give you 21.46. And now we need to carry out a goodness of fit test at 5% significance level. For goodness of fit, this is the keyword in questions. We always use chi-squared test. So chi-squared is equal to the sum of observed value minus expectation value squared over expectation value squared. So we do that for each element on the expected frequency and observed frequency. So this is OI is EI, and we sum them up. That will give us 11.3, which if we look on the table, is less than chi 6.95 squared. And when we are carrying out goodness of fit test, we always do the number of points minus 1, which is called the degree of freedom. And because the chi-square in this case is less than the tabular value, the distribution fits observation, and we accept H0. Question 10. Samples of rock from a number of geological sites were analyzed for the quantities of two types, X and Y, of rare minerals. The results in milligrams for 10 randomly chosen samples, each of 10 kilograms, are summarized as follows. Find the product moment correlation coefficient. Well, R has a rather scary formula, X as xy over the product sxx as yy, where sxx is equal to the sum of x squared minus sum of x all squared over n, and similarly syy is equal to the sum of y squared minus that, and sxy is defined to be that. And after plugging the numbers, we'll find R to be 0.687. The next part, stating your hypothesis test at the 5% significance level whether there is a non-zero correlation between quantities of the two rare minerals. So H0 is rho is 0, there's no correlation, and H1 is rho is not equal to 0. So for R at 5% significance value, and 10 chosen samples, we shall have 0.632, and we see that 0.687 is greater than 0.632, so we can conclude that there is a correlation. And find the equation of regression line of x on y in the form x equals py minus plus q, where p and q are constants to be determined. Well, the form would be x minus x bar equals py minus y bar, where p is equal to sxy over syy, so x on y equation, and we will find that x minus 86.6 is equal to 1.2 y minus 63.9. And rearrange, we shall find that x is equal to 1.2y plus 9.92. And question 11. So question 1 show that AB is 4A and the angle SAB is 30 degrees. It's very easy if you spot the fact that there's a right angle triangle here. Let's call this point X. So AX has length 6A minus 4A, so it's 2A. And XB has length 2 root 3A. So AB would just be the square root of 12 squared plus 4 squared, 12A squared plus 4A squared, and that will give you 4A. And after finding AB, we can further find that the angle CAB is the inverse sine of 2A root 3 over 4A. That would be 60 degrees. So as AB is just 90 minus 60 equals 30 degrees. And now I want to show that normal reaction at A, point A, is a half W. For the second part, we need to resolve forces, and let's do it in the vertical and horizontal direction. So in vertical direction, we have a half and A, so NA is the reaction force at A, pointing at the upwards direction, plus a half root 3 MB, so it's the reaction force at B, pointing in the upwards direction. And where a half root 3 is just found by working out the correct angle, and plus a half root 3, the friction provided at A must be equal to the weight because the system is in equilibrium. And horizontally, these forces must also balance themselves out. So we have another equation. And by solving this simultaneous equation, I eliminate MB plus FA. We have NA is equal to a half W. And the third part of the question, we want to find the frictional force at point A. So in order to do that, we need to resolve forces in the direction of PQ to find NA. So from the first part, we know that NA is a half W. And in the direction PS, so this direction PQ, in the direction PS, we find that MB plus FA is equal to a half root 3 W. And now we take moment about A. So you can take moment about any other point as long as it's sensible, but A in this case is the best choice. We have a half 3W times 3A over 2. This is the moment of the weight, plus a half W times A is equal to MB times 2A. So solving this, we get MB is equal to 7 root 3 minus 6 all over 8 W. And if we have MB, remember the resolution equation from the last part where we resolve forces horizontally and vertically. So we can then find FA from MB. So FA is equal to root 3 NA minus MB, and that will be 3. So minus root 3 over 8 W. Okay. So the second choice of question 11, the time taken for a randomly chosen student at college B to complete a particular puzzle has a normal distribution with mean mu minutes. The times x minutes are recorded for a random sample of A students chosen from the college. The results are summarized as follows. Find a 95% confidence interval for mu. Well, to start off with, we need to find the estimate population variance, SP squared, and that will be 236.0 minus 42.8 squared minus 8. So this is just utilizing the data and divided by A minus 1 to make it an unbiased estimate. And that will give us 1.113. And the confidence interval will just be confidence interval will just be 42.8 over 8 plus or minus t over the unbiased estimate for population variance, SP squared, over 8. And from the tabular value, we know that for 0.85, because this is a two-tailed test, so if we need a 95% confidence interval, we need to find the tabular value for 7, 0.975, and that is found to be 2.365. And 2.35 plus or minus 0.84 is the correct confidence interval. And now a test is carried out on this sample data. At the 10% significance level, the test supposed to claim that mu is greater than k, find the greatest possible value of k. Well, we need to solve for k max. So 5.35, our confidence interval, minus k is greater or equal to 0.5. So k max is greater, k max is equal to 4.85. And the hypothesis would, for the last part, a random sample of size 12 is taken from the students at college Q. Their time to complete the puzzle gives a sample mean of 4.6 minutes and an unbiased variance estimate of 1.962 minutes squared. Use a two-sample test at the 10% significance level to test whether the mean time for students at college Q to complete the puzzle is less than the mean time for student psychology P to complete the puzzle, we should state any assumptions necessary for the test to be valid. Well, the assumption in this case are quite. The things you can say is that the college Q distribution has also a normal distribution, and the sample also has normal distribution for P and Q, and they must have equal variances to start with. And the null hypothesis in this case is that the mean is the same, mu P equals mu Q, and the alternative hypothesis is that they're not equal. The alternative hypothesis in this case is that the mean of P is greater than the mean of Q. And if we find the estimate pooled common variance s squared, we'll find that to be 1.59a, and the value of t, as mentioned before, is found to be 1.3, and it's less than t 18.9. So we need to reject the alternative hypothesis and then keep H0.